in France, in the US, but also in Korea and China. And the international project was then started to kind of realign all the different developments. The project has been officially started in, I think, end of January and beginning of February this year. And we have different work packages. The different work package, the first work package was the requirements analysis, which has been almost finished. So we are a little bit late with this because we have faced more problems that we have expected to do that, but we hope to finish it very soon. At the same time, we have already started to define a taxonomy. So this is, I would say, already part of the solution, the taxonomy, and we are already in the process of defining the properties of the individual elements. As soon as we have this, we will also define a mapping from the new elements to the IFC elements and identify where we need extensions of the IFC standard and where we can make use of the existing elements and reuse them also for the bridges. Yeah, that's the current state. So in total, this will be a 2 years project. So we hope to finish the project in January 2019. So we have a little bit more than 1 year to go. I would say it's still achievable. I think we have made good progress, especially with respect to the taxonomy and the properties. And this will provide a very good basis then for defining the actual data structures. So I would say that from this point of view, we are in a good shape and a good position. Okay, so any questions about the project as a whole? Okay, if not, then I jump.
Andre, can I just jump in?
Yes.
Just to explain sure. For the experts that are joining us today, if you do have a question, there are 2 ways in which you can let us know. One is you can actually send us questions. So there should be a question pane for you, a little panel where you can add your question. You can also do that through the chat. And you could also raise your hand. Raising your hand is the easiest. That way I can give you, unmute your microphone. Because it's a webinar, a lot of people can join and your microphone is muted automatically. So if you want to ask a question, please feel free to do so. Just raise your hand and I can unmute you. Okay, that was all I wanted to add, Andre. Thank you.
Yeah, thank you. Thank you, Laura. So if you agree, I would now share my screen. Oh, no, this was the webcam, sorry. Screen is here. So I hope that everyone can see my screen. Sorry. So this is the document that we have created as a result of the work package 1, the requirements analysis. We have worked on it throughout the last month, so it's still changing. So we take into account the feedback that we are receiving, also from you as the expert panel. We are still in a draft mode, but we hope to finish this report very soon. So first, the document talks about the methodology and the overview of the IFC Bridge project. It talks about the different national initiatives that are used as a basis for this international project, both from the viewpoint of developments regarding the express schema, but also with respect to organizing feedback for developments that we have developed here. So We then define the bridge types that are covered by our project here. We focus on slab bridges, girder bridges, frame bridges, rigid frame bridges, and culverts. We believe that our extensions will also be sufficient to describe truss bridges, arc bridges, cantilever bridges, cable stayed bridges, and suspension bridges. However, we decided, because this is a fast-track project with a limited time and also with limited resources, we decided to no validation tests for these kind of bridges. So these bridges here in the upper part, we will create validation test examples to show that our extensions are able to support this kind of bridges, but for the lower ones not, because also these ones are not as widespread as the ones above. So sorry. From a material viewpoint, we will support reinforced concrete bridges, pre-stressed concrete bridges, steel and concrete composite bridges, steel girder bridges, and steel bridges. Then we have quite a comprehensive list of use cases. These use case tables have a number, then the use case as a short description, including a short description, then the purpose, so why do we need this use case, the actual IFC exchange scenario, so who is sending IFC data, who is receiving IFC data, which applications, and then a short and quite rough description of the geometry representation required and the required semantic information. So of course, especially with respect to the semantic information, this is by far not complete. In the end, we will have a very fine-grained list of this information for individual elements in our bridges, but this is to just define an overview of information that is required here. We then have decided on priority. So will this be included in this project or not? If the priority is high, then it is most probably included. We also assess the complexity of the different use cases, especially with respect to the required extensions and also with respect to the geometry needs. And from these two fields, actually, the decision is taken whether to include the use cases in this fast-track project or not. What we also have in the table is the proposed MVD. I will come back to this later on. But in general, the MVD will be a model view that we define within our project, which then has different demands with respect to what kind of information is supported by the receiving application and the writing application. Like, for example, alignment is a specific extension of IFC, and whether to demand support for alignment or not heavily depends on the use case. So we here make use of the MVDs that we describe later on for each individual use case. So what we have as use cases is initial state modeling, import of alignment and road or railway parameters, technical visualization, coordination and collision detection, 4D construction sequence modeling, quantity takeoff, progress monitoring, as built versus as planned comparison, handover to asset management, handover to GIS for spatial analysis, design to design, but here only as a reference model, so something that is not modifiable is included. Design to design with the full model logic, including all the different parametrics and dependencies, is not supported because the complexity is too high. Design to construction is included with medium complexity, but high priority. We are not including structure analysis because here the priority is medium and the complexity is medium to high. Also, code compliance checking is not included. Drawing generation is not included. Prefabrication and manufacturing is also not included here. So yeah, in the next part, the in-scope and out-of-scope decisions are kind of explained in more detail. And then we have a section on geometry, and we explain what kind of geometry is required for which use case, how the dependencies are, and what exactly for example, the use of sweepings means with respect to the geometry to be supported, like IFC section, solid horizontal, or swept area solid, and so on. So the next is the definition of the model views. Here we have defined, as I said before, 4 different model views with different demands regarding mostly the geometry, but also the semantic aspects. The most basic one is the bridge reference view, which will be very much aligned with the IFC 4 reference view, which has only explicit geometry, which supports mostly the use case of visualization and coordination in quantity takeoff. So this is also be usable here. In addition, we have defined the alignment-based bridge reference view. This reference view will make use of alignment for positioning and orientating of individual elements, but mostly will still make use of explicit geometry to describe the surface of the different elements. Then we have the bridge design transfer view, again very much aligned to the IFC 4 design transfer view, but here again with support for alignment. And finally, we have the bridge asset management handover view, but here we did not define yet the content, so this is something we will have to work on in the future. This part here describes what actually is included in the different views. I will not go through this because we do not have that much time today, but of course you have this, it was distributed with the document. And yeah, then we have this table here, which shows you well, I would say the most important components of the different model views. Most importantly, we have here the already existing IFC4 reference view in white, and IFC4 design transfer view also in white, and in orange the newly defined reference view for the bridge, the alignment-based reference view, and the design transfer view. And you can see that the reference view is pretty much aligned with the IFC4 reference view, and the design transfer view is aligned with the bridge design transfer view is aligned with the IFC4 design transfer view. However, we have some differences here, for example, with respect to IFC section solid horizontal, which is supported by the alignment-based reference view, but not by the bridge reference view. So here we have a difference, and of course we also have a difference with respect to the alignment curve, to the distance expression, the orientation expression, and the linear placement, because these are all elements required for alignment-based geometry descriptions. And the alignment itself, of course, also is only supported in the bridge alignment-based reference view, but not the reference view. So in essence, you will be able to open and visualize our bridge models in the bridge reference view. Also, if you have a conventional IFC viewer, which is not capable of supporting alignment, This is important to have this kind of downwards compatibility with the existing elements. Sorry. Then we have a very, very long section about data requirements, where we started to identify for individual items what are the requirements for the different components of a bridge, which with respect to the different attributes. Here we use a color scheme where red means this is kind of the primary key of an element. Orange means this is a reference to data in another table. Yellow means this is required data specific to the object, and green means this is optional data. So let's have a look on this. We have here the project with a number of green elements and also an orange element. Green means optional, orange means reference object. We have the site object, which has the elevation, the surface proposed and surface existing as mandatory elements. We have the alignment itself, the bridge itself. We have the piers and abutments. We have the footing. We have the pile, the bearing, the girder segment, the cross frame, and the deck segment, the parapet, electrical box, the rebar array, and the rebar shape. And we will also include, this is not included here, but we will also include information about pre-stressing systems. It's not in this version, but it will be part of the next version. Then we have the soil boring point and material information, traffic lane information. Yeah, and that's it for the moment. We still need to harmonize this view with the taxonomy we have created already for work package 2. So yeah, it's, as I said, not yet completely final, but it gives a good overview of what has been done so far and of the requirements we have defined so far. So the next step will to use these elements we have defined here and go forward and then define the model view definitions and the actual extension in more detail as part of work package 2. Okay, so this is the short overview of the requirements analysis, and yeah, I'm happy to answer any questions that might arise about this requirements analysis.
So again, just also for those that have just joined us, if you would like to ask a question, you can do so in various manners. The easiest way is to raise your hand. There's a button and it's called raise your hand. That way I can unmute your microphone for you. So please feel free to ask any questions to Andre. I'm more than happy to unmute.
And of course, if you are not able to already raise a question today, you are always free to send us an email with your input, with your proposed changes in this document, and we will try to incorporate as much as possible.
So Andre, there's one hand raised by Rodrigo. Rodrigo, yes. Go ahead.
Good afternoon. Maybe I don't know if it's exactly within the scope of the project, but it would be nice to have a definition of the different types covered. I mean, just a definition of a slab bridge, girder bridge, frame bridge, rigid frame bridge, which I can't find the difference between the frame bridge and a rigid frame bridge. And it would be very nice if those have a definition.
Okay, I agree, and we will try to give this definition. I think we have good examples from our Chinese partners and we will ask them for permission to include also the pictures they have about these kind of bridges.
Thank you.
Thank you, Rodrigo. And any other questions from any other members? I'm not seeing any other hands raised. Do you want to give them a couple more minutes, Andre, or?
No, I think it's fine. I would expect that everyone might have a closer look on the report on the current state of the report, and then send us his feedback via email. I think maybe this is even more productive than discussing everything here.
Good point.
Okay, so I propose that we then jump to the next agenda item, which would be, I guess, the presentation of Sergey, right?
Sorry. Taxonomy, yes. Sergey's next. Sergey, would you like me to make you presenter?
Yes, please.
There you go.
So let me start off by explaining what exactly we want to achieve with bridge classification. So to actually model a bridge, we have to know what kind of objects we should represent, and these objects will then be somehow somehow mapped to existing IFC entities. If we cannot find a suitable one, we will define a new one. And for that purpose, we already presented the basic workflow of how we are planning on doing this. So at first we had these taxonomy sheets. We also showed them several times at our expert panels already. These were just basic sheets with lists of elements. We also have a similar Excel sheet for properties, which is the data dictionary defined by Mind. This is probably the only input that we have regarding properties. So if you have any other Excel sheets, maybe PDF lists of properties, they would be very welcome in the definitions of the P sets that we will do shortly after the taxonomy is accepted. And with these two input generated data, we will then generate the IFC documentation in IFC doc, and we will be using BIMQ, which is an online database for defining guidelines to map the taxonomy I will be showing here to the IFC elements. So let me first just explain why we have a certain structure to it. It's by no means something that should be firmly taken over to the standards. By that I mean that we should probably consider having a certain structure of IFC files, but it's not necessary that we will have a breakdown between carried elements, superstructure, substructure, reinforcement, and temporary works. These are mainly national, and therefore MVDs should be developed by local chapters also to define how exactly an IFC bridge file should look like. The breakdown you see here, so carried elements, superstructure, and so on, is just a way to organize the elements and have an easier flow of information for you to give us feedback. We did receive some feedback on this from the Japan chapter and from the Nordic chapter already. Thank you for that. It's very good input. But even though we are currently not yet considering the systems or spatial structures or whatever should be used, in the end we will definitely be using feedback for that also. So let me just jump over quickly how these things look like. We had taxonomy sheets, we have the data dictionary from the MIND project, and then we are using IFC doc for concept template definitions and for documentation generation, and we're also using BIMQ as the platform where we will map the elements from taxonomy that I will be showing next, and IFC entities in the end, which will be then also used to generate an MVD XML and used as a basis in IFC doc to generate the documentation. I'm sorry about that. My computer just went crazy. In any case, let's just start again here. So how we see the breakdown of elements in groups is approximately this. We have a carried system, which is not part of the bridge structure, so should not be covered, is out of scope of this project. And we have a supporting system, the superstructure. We have the load-bearing system, which is the substructure, and we have a foundation system. This is taken from the MIND project. It's by no means a final version of how an IFC file should look like, but it's definitely useful to be considered as such. So let's go to carried elements. At first, as I stated, our in-scope definition would be something like this. The bridge is a structure built to span physical obstacles without closing the way underneath. So everything that can be grouped under this basic definition is in scope from our point of view. Anything that's not that does not fit into this basic definition should be out of scope. So anything like sign systems, safety systems, drainage, carriageway, and so on is not in scope of IFC bridge. It's definitely needed for IFC bridge, but we should look to other projects to define this or use the existing schema to define these carried systems. I have a few examples here. It's something that should be used in the common schema project also, so we're happy to transfer this information to the common schema later. But before we start with this one, this is what I was looking for. With a superstructure, let me just address the survey we had sent out. So we had a special survey, and we got some information regarding that, where we basically just asked you experts of what you actually want from a bridge model. What objects do you see as part of a bridge model? These were then defined here with in this presentation as pictures and a short description, and you were asked to give us feedback if this is something you see as part of the bridge model, or if you see it as part of the common schema, or part of the road, part of rail, and so on. Because this is something that will be used to define our extensions to the schema eventually. Laura, a question.
Yes.
How can I start a poll?
You do that.
Do we still have them?
Yeah. So you would ask me to start one.
Okay. So let's start one. This next part, I would like some input from our experts, where Laura will start a poll. We will look at the elements there, and you just click on the ones that you see as part of the bridge model when you're receiving data. What do you see as the objects that should come in this model? So did we start the poll?
Yes, every expert should be able to see the poll now.
Can I see it also? Or am I missing something? Maybe.
I'm seeing it, but it could be because I have different rights than you.
Okay.
But I can let you know. They're giving their answers now.
Which objects do we have listed in the first poll?
Deck, girder, diaphragm, truss. I'm not even sure how to pronounce that last one. Parapet?
Parapet, yes. So these are the first 5 that I would like some feedback from you. So a deck represents the surface of a bridge. Girder, horizontal support beam. Diaphragm, some feedback from the Nordic chapter told us that we might want to rename it to cross beam. So either diaphragm or cross beam, whatever suits you best, as long as we know what we're talking about. So trusses and parapets. Laura, could you just give me some feedback? Do we?
Yes, we're getting
the poll.
They're collecting them right now.
Perfect. Thank you.
So 71
makes me very happy.
71% of the experts have voted. So whenever you're ready to close it, we could. Andre, do you want to say something? You're unmuted.
No, I don't know actually how this happened. I'm sorry.
Okay, now there's less feedback because I was hearing myself as an echo. That was quite confusing. 71% has voted and it's staying stable, so I would suggest close the poll.
Let's just move on. Let's go to the next one. And if you could fill me in which objects are there so that I go through them quickly.
Okay, so we're going on to the second question by Sergey, and it would be about expansion joint, shock absorber, beam falling prevention device, approach slab, and cornice. As soon as I launch the poll, it'll take over your screen. So do you want to go through it first and then answer the question?
Yes, let's go through it first. So what we would like to know here is, do you see an expansion joint, which would be, from our definition, an assembly connection between construction elements to allow for thermic differential expansions? The shock absorber damper, we're still considering this because we already have some special elements designed for that, how to group them or what the super class should be regarding this. So the device designed to absorb shock impulses. beam falling prevention device. I guess it's a device to prevent the falling of beams. Slab located between bridge and roadway abutments. We already have some feedback from the Nordic team on that also, which would be that it should be grouped under substructure, since it's a part of abutment. Not that important currently, but definitely important when we continue with the project. And the last one was
cornice.
And the last one was cornice. So this bridge shoulder part, or how to call this exactly here. And I would just start the poll. So do you see these elements as part of the bridge model or not? Let's just open the poll.
The poll has been launched. So please, could you let Sergey know if information on these elements would be needed when you receive a file on bridges? So people are filling it out. About 17% have voted. Let's give them a couple of minutes.
I will leave the pictures open here. Maybe make it bigger. If there are any questions, we can probably still answer them during the poll, right?
Yes, of course. So you can also raise their hands if you have questions.
Right. So if you're not certain about an element, please ask.
%63% of the experts have voted. I would love to see a couple more, but we have some questions here. We have Karen. I'm going to unmute you, or I'm trying to. It's being a little bit difficult. I'm sorry.
Yeah, I think the poll is taking up some resources because I'm having difficulties switching between applications also.
Okay, so I can unmute Rodrigo. I think, Karen, have you muted yourself? Because then I cannot unmute you either. Can you try and unmute yourself, Karen? Well, I'm going to try and chat to Karen in a minute. Maybe we can take Rodrigo's question first.
Sure.
Rodrigo, go ahead.
Yes. Again, the question of definition. Here we have now on the pool we have a cornice that it could be. I don't know if sometimes can be included with the parapet, or the parapets also including handrails of barriers, protection barriers for traffic. I think so. This should be a bit more clarified.
Well, if it's a separate element and if it's modeled as such, I think the cornice would be, I mean, it's not necessary that you always have a parapet and that you always have a railing, I think. I mean, I'm not sure. So in case you have a separate element cornice, would you like that to be modeled separately? Would you like to have information on it as a separate element, or would you like to have it as a part of the deck, part of the railing, part of the parapet, for example?
Yeah, the problem I foresee is that sometimes it will be difficult to make a difference of of the purpose. It could be a parapet and the cornice can be in a single piece or element, or it can be two different parts. I mean,
well, sure.
It can cause some problems on the definition of the element, or to recognize it.
I wouldn't see that as part of the issue. The standard has to address the schema. IFC schema has to address. That's more of a problem of the modeler. If the modeler wants to have one element, he should model it as such. If he does not, he should model it as two elements. Wouldn't you agree?
Yeah, thank you. Yes. But
the standard has to incorporate both options.
Yeah, I do agree. But yeah, I mean, I'm thinking just when you are doing some kind of verification or quantities takeoffs, things like this, to be sure that it's considered as it is. And it's you could model maybe a parapet as a cornice, and then if you're asking for how many meters of cornice you have, there goes a parapet. That's the problem I can see. It happened with other elements anyway. Thank you.
Yeah, we could definitely see such an issue, but I don't think it's an issue of the schema. It's more of an issue of exchange requirements and modeling, and the modeling software or the modeler himself, how he models these elements. If you have the exchange requirements defined that you need two separate elements, so a cornice and a parapet, then if those exchange requirements are checked and you don't have two elements, you have a parapet, for example, missing, you should probably go back to the modeler and tell him he did something wrong.
Okay, that is good. Okay, I agree. I mean, it's clarified for me.
Okay.
Sergey?
Yes.
I got an email from Karen. She sadly doesn't have sound, so something's going wrong technically on her side. And she said approach slab should be transition slab. So I'm assuming the fourth one. That's where she has some feedback on.
Okay.
Do you want me to add it in the chat so we don't forget?
Yeah, sure, do it. Let's just add it to the minutes later, and we will consider this. I think if it's just an issue of how it's named, we could definitely cover both options. So.
I suggest we then close this poll, so thank you.
Okay, let's do that.
The third poll is about bracing and strut. Is there someone in your background talking, Sergey?
Yes, there is.
Okay.
I'm sorry for that, but I cannot remove myself from the office.
It's okay. I was just wondering where it was coming from. Don't worry.
Just a second. Okay. So cornice and brace. No, we had bracing and strut, right?
Sorry. Yes, bracing and strut.
Bracing and strut. Looking at bracing, so this would be lateral support for sorry, this is not what I wanted to say, but lateral support for structures, just general, and struts, linear elements used within a girder or truss as compression elements. So these would be over here, these diagonal compression elements. Would you see these two elements as something you would want from a bridge model when you receive it, or is it not important.
So we've launched the poll again. 21% is voting. So I'll let you know when we get to 71%. And if anyone has, please raise their hand and Sergey can answer it for you. We're almost there. %67% have voted, so I guess we're waiting on one more person. Seems to be staying stable at 67. What would you like to do, Sergey? Close it and move on to the next one?
Yes, let's close it. It should be representative, I think.
So the next ones are about abutment, retaining wall, bridge, apron, arch, and bearing. Abutment through to bearing.
So let's quickly go over the elements here. Abutment, substructure at the ends of the bridge supporting the superstructure, can be comprised of walls, of course, which are basically wing walls, head walls, stem walls, and also cones. This would be more or less an assembly of different walls acting as the support at the ends of the bridge. So going further to retaining wall, is this is also could be a separate element, of course, works a bit differently than a normal wall. Then we have bridge apron. Bridge aprons are devices to protect the river bank or bed against scour. They act like a shield, so the foundation does not get the material around the foundation does not get eroded. And we also have arches, which would be structure elements of an arch bridge. And the last one, bearings, so elements where deck rests on the pier or abutment, allowing which allow, okay, maybe not only horizontal movement, but movement in general. So the question here again, when you're receiving a bridge model, do you see that these elements, these 5 elements are required, or do you not need them when getting a bridge model?
We're getting a good response here, 42%. A couple more and we'll be up to some representative amount. Um, 67% have voted.
I think that's the number where we have settled on.
Mm-hmm.
So let's just move to the next poll.
Would you like me to share the outcome of it, just to show everyone what it looks like?
Sure, why not?
So I don't know if you can now also see it, Sergey. Has it taken over, or?
Unfortunately, I don't see it.
Can you stop sharing your screen for 1 second to see if that would help?
Let's do that. I cannot really stop sharing my screen.
Okay.
I only have a pause button, but that one just freezes the screen.
Let's not make it difficult. Continue.
Yep.
So the next elements are pier through to springer. Pier, footing, pile, and springer.
So let's go over these elements again quickly. Piers, what we understand as piers are vertical supports. Elements that we see also being part of the pier are cap beam, wall pier, bedstone, and hammerhead. Next one, footing. This one's pretty obvious, support in the ground usually. Then we have piles, which would be foundations driven into the ground. So deeper than of course normal footing, and we also see pile cap on top of them to connect them. Next, springers, which would be these elements here. So these are the first elements of an arch. I'm not sure if these are still in use in modern bridges, so this is definitely something I would like to see some feedback for. Or if they are, then I would appreciate that getting some feedback in images or maybe breakdowns how these elements are structured, because I really haven't found anything useful on the internet apart from this old bridge here. Okay. So again, the question is, when you're getting a bridge model, do you see these elements as required? Do you need information on them or not?
So, Sergey, for your information, the poll has been launched. We've gotten 54 votes already, and we're just waiting for a couple of more. So we're up to 67. Everyone does agree on pier, footing, and pile. 100% for all of those. 71% have voted, thank you, that's wonderful. And 18% say that Springer should also be added. So I guess the next question would be, for those people that have said, yes, we would also like to receive information on Springer, if you could please send any, what did you say? Plans, documents, breakdown?
Any documents. Images would be welcome also in the first phase, but eventually, if you want to put some semantics on such elements, definitely some plans, some breakdown specification, maybe even.
I'm just adding it to the chat. Your email address is that sm@aec3.de?
Yes, that's me.
Okay. So add it into the chat just as a reminder to everyone, especially those that have said that Springer is important. Please send any documentation you have on that to Sergey, and his email address is added in the chat. So 75% have voted. Wonderful, thank you. Are you ready to close this one and continue on to the next?
Yeah, let's do that.
Okay, so the next one is on reinforcement bar, pre-stressing systems, deviator, anchor, and tendon.
In this group, so the reinforcement and pre-stressing group, I mainly just gathered elements that are used in reinforced concrete or pre-stressed concrete. So there are, of course, probably several more. That's why we also had a breakdown in the next image, which I will show. So reinforcement bar, these are obvious. I won't go into further detail, but this image here, for example, is a lot more complicated. So where, thanks to Mind again for this breakdown, it's very detailed. But just to have an overview of how detailed pre-stressed systems could get, and would you require this kind of detailed breakdown when receiving an IFC file? This is the main issue here. So pre-stressing systems, just having this extremely detailed breakdown, is it necessary or not? Just more of a general question, yes or no. And if you say yes, then I would ask you to send me your view of how detailed a pre-stressing system should be. Because what we do have is, okay, these are special elements for pre-stressing, so deviators where we redirect the tendon with a particular structure. Then we have anchors. So for example, this is something probably, so this would already be possible to model in the current IFC schema, but is it enough to just have anchors and tendons, for example, or would you really like these detailed breakdowns in a bridge model? So this is a very important issue, and if you really see such a detailed breakdown to be of benefit, please tell me what your view of this would be.
Okay, so we're launching the poll again. If you could please let us know which of these elements you would like to see in a bridge file. And anyone with any questions about definitions, please raise your hand, and Sergey will gladly answer those for you. So just for Sergey's information, because he cannot see my screen, we're collecting the responses right now. We're up to 50%. So I would suggest let's give him a couple more minutes to get 75%.
Yes, these are a bit more detailed and complicated, I guess. It's not just basic bridge elements. So. So just to explain once more, the pre-stressing systems here, if you vote for yes, I would be very glad if you could send me your view of this breakdown. Does it have to be this detailed that this image here shows, or can it be, can it have fewer elements, or if it's even more detailed, what you require, then that would make sense also. Just if you vote yes, please, I would ask for some additional documentation and feedback.
I've also added that question of yours to the chat, Sergey, for you. I've tried to describe it as best I can. We're up to 71% and we're staying quite stable. So if you're willing to close it, you can. I
71%.
One raised hand from Rodrigo. Rodrigo, go ahead.
Let's do that first.
Sergey, excuse me for
No.
calling you again.
Go ahead.
The system, prescription system, which is located normally in a kind of diaphragm. I don't know if that diaphragm where all the prescription systems are placed, it should be a singular element on the specification. It would be treated as an element. Because that's very different from the other diaphragms, and usually there is a place where a lot of conflicts.
Well, it's not such a pre-stressing system is not only in the diaphragm; it's in the entire structure of the bridge, because you have to somehow pre-stress the entire span, not only the diaphragm.
No, I am asking the anchoring of the anchoring elements. I mean, I'm probably thinking just on the two ends of the tendons. It needs a very good definition, a very good design. That's, I was thinking that in those diagrams, not in a common one.
Oh, we were not talking about the cross beam that we were talking about before and the superstructure elements. You're talking about such anchors.
Yeah. Well, you anchor all the tendons and both ends, which usually is a very difficult part of the structure to build and to execute, and you have plenty of conflicts over there. I think so. There you need to really, BIM will be a very good help.
Do you have a certain idea of how detailed you would like to model anchors?
Not really.
Not really.
I am almost keen in how it will facilitate my job. Usually I'm a supervisor and I'm a project.
I think we will have a certain proposal from one of our project team members, Claude Dumoulin, about pre-stressing systems. So that would be something we could distribute among the expert panel and get some feedback on that. But I'm not sure if it may be detailed enough for you, because we kind of settled on not having a too detailed system represented in IFC.
Yeah. I understand now. Well, we are starting. You are pushing hard for these things, so I know this have to be increasing with the time and learning path. But actually, in some places, they are already thinking prefabricating parts, elements,
right,
on factory for this area, because it takes a lot of detail and very good positioning of everything, because there are too many things there. And if you're doing...
Yeah, please. Sorry for interrupting. I thought you were done.
No, that's the idea. I mean, it will be maybe in short time will be some elements coming from outside, from prefab. It will be included on the project. That's the reason I was thinking that it could be an element covering these issues.
Yeah, that's why we have a dedicated anchor listed also. But if you really have some idea of how this anchor should be structured, I mean, we have relationships in IFC, so we can model an anchor composed of other elements. It would make sense that if you have just a diagram, how you would see this for concepts that will have to be developed of how to model certain objects, we could use that as we use that as basis, definitely.
Okay, I am not an expert. I will try to. Thank you very much.
Thank you. How are we doing?
We're doing good, although I'm having technical issues.
What's the poll?
The poll is closed. Can you still hear me?
Okay. Yes, I do.
Okay.
I hear you.
There are some technical issues on my side, so if you could be a little bit patient with my response, that would be wonderful. It might take me a minute to get things working.
I'll try.
Thank you. Let's see. The next one is on conduit and blister.
So the next two elements are also part of the pre-stressing part of bridges. And first of all, the conduits would be the channels for housing bridge tracing tendons, which are then filled with concrete in the end. This would be the conduits, and we have blisters, so parts where actually we anchor the cables into the structure of the bridge, so into the main structure of the bridge.
So again, the same question.
So we start the poll?
Yep. Go ahead. Yeah, the poll has been started. So again, if you have any questions towards Sergey regarding definitions, please raise your hand, or any feedback you would like to bring in, please feel free to raise your hand. So Sergey, it's up to 67 now.
Let's wait a few seconds more.
It's staying stable.
67 still?
Yep.
Okay, let's go on. It's just 2 elements.
We're almost there. Question number 8 out of 9. This one's about launching nose, launching gantry, staying mast, casting bed, and pushing jack.
Okay, so what we see here is temporary elements for constructing bridges. And these elements are usually removed, of course, after the bridge is constructed. Again, if you're transferring data for bridges, would you require information about these elements or not? So for the launching node, would be forward construction in an incremental building, so this temporary beam sticking out the segment being pushed. A similar device, but this one transports the entire segment between 2 gears, then sets it. Then we have the staying mast, so constructions here, temporary pylons, casting bed, so construction site for segments in incremental construction. Basically, just the initial part where the segment is constructed and then pushed. And last one, we had the pulling or pushing jack. Depends on if we are pushing the construction. So this would be the mechanical device with which in incremental construction we are pushing the segments.
At least at my side of the webinar, it seems to be a little bit slow. So I'm not sure if everyone got to see everything you were clicking on, Sergey. Would you like me to launch the next question? A little
Yeah, let's do that.
bit. So we've got a question from Siva. Siva, please.
Hi.
Hi.
This can come from a different perspective also, because during construction phase, I come from a asset management end of the life. So in that perspective, we may not need to know these temporary structures, but during the construction phase, whether the project managers do require it or not is a question. So from my perspective, I say I wouldn't really sort of need them, but maybe there is a phase in which somebody would need it, could need it. I don't really know.
That's a valid point.
And Sergey, Andrew would also like to join in here. Andrew?
Hi all, thanks very much for the opportunity. I'm interested in what you guys are talking about and whether or not you have that detail of definition. Now, regarding the last speaker, obviously during construction, you will need this to do several things. And don't forget that the more granular we go with the definitions, the simpler it will be to validate and check things. So we'll check things that are there or not, check tolerances, check the actual listing of the element, check allowed elements that should be or should not be in the system. So from an overall cross-sectional point of view, just as a general comment, the more granular we go with the definitions, the simpler it will be to actually allocate definitions to items that can then be validated, listed, and checked. Thank you.
Just a note on that. If we're looking at IFC, we have to also be clear on that at certain point we cannot really expect that the manufacturers of certain elements will give the engineers all the data required for, I don't know, such granular modeling.
But I think what needs to be decided is how far we can go. We will, for example, I know with some engineering companies that they're finding a lot of difficulty in making sure that things fit, for example. Now, if you have a definition of, say, reinforcing or boots or tendons or whatever you like to have, that are not defined, then you can't find them. And if you can't find them, you are in trouble, because then they'll slip by.
Indeed. I completely agree on that, of course. but yes, this is definitely a point where I would like feedback from your side, because I myself am not a bridge expert and I don't know what exactly is needed. So
Sergey?
if you find, yes.
Sorry, Siva, I think once in there. So Siva, go ahead.
And then no, it's all right. I agree with the other user that at various phases you will really sort of need these for different times, which is again the same point that I made. But to the degree to which you want is really for that for those it's that sufficient experience in the project management, the construction phase, only can provide you with.
Yeah, so this is what I wanted to say before. If you do not find it relevant, maybe just leave out the question if you think your answers could influence the outcome of the poll.
Yeah, that's exactly what I did. From my perspective, I have not, but then that shouldn't really sort of mean that it may not be required from the point of view of. Yeah.
Exactly, because these are different exchange requirements that you guys have, and so if you just do not find it relevant, maybe just leave out the question and be done with it.
Thank you.
I think we already see that in the answers themselves. I can share it with the attendees, but I can't show you, Sergey. What you see here is that for a while in the past polls, it was up to 94% on almost all elements. You now see launching nodes and launching gantry are only 50% of the experts have voted as they would like to have that element. So I think what you asked them to do has been done. So they haven't answered it if they have a different requirement. Okay. I'll make sure I get you these print screens to you after you have that input, because you can't see it right now. I think we only have one more to go, right?
Yes.
Which is launching bearings and soil borings.
Let me just check if my screen is coming through. Okay. So launching bearings would be the bearings allowing for launching. Of course, these bearings are a bit special because you have to allow lateral movement of the segments to actually move them to the piers, of course. And then the last one that we have in our list, sorry about that, is the soil borings. From what I understood is that also rail and road experts require those. So maybe it's not only necessary for bridges, but let's just have that in scope for bridges. Do we require soil borings or not when exchanging bridge models? We can launch. Okay, it's already open. Sorry.
No worries.
I think even if someone has different exchange requirements than, for example, what we're looking at here, and does not leave out the question, I think we should still have a firm grasp of what's required and what's not.
We're up to 63%, and not everyone might vote on this because it's not as important for everyone, as you said before.
Right. Unfortunately, these polls in GoTo are not as flexible as the ones we sent out before, where you can leave your own comments. So it might not be the best outcome, but still, it's better than nothing. And any input will do.
Yeah, but they do have a questions panel where they can add questions, and you also have a chat. So if you want to provide any other feedback, please feel free to do so. Rodrigo is asking a question, Sergey. He's asking, what about false work? I'm just going to unmute Rodrigo here and ask if he can maybe explain a little bit more. Rodrigo?
Yes, please.
Yes. I mean, if you're doing in situ bridge and you are supporting the formwork from the ground, that should be included in the. I believe it should be included in the bridge project. I don't know if it could be just included as a structural model of not a bridge model, but it's something that the bridge projects should come with. How it's going to be that false work is going to be provided.
Again, I would ask you if you have any documentation on that. Just send it to me. I will look through it and try to identify the required objects, elements that we should use in our taxonomy.
Yeah, well, my point is that it should be with the bridge project, the taxonomy and everything. Elements will be normally steel members, pipes and angles and crosses. That's that kind of a structure. I mean, that's I don't know if it will be. If
it's only that, it's not that critical to have any special elements, because a beam is a beam. If it's temporary or if it's permanent, I don't see a difference other than time.
No, okay. No, I agree with that. I mean, but I mean the whole project should include this false work. I mean, the element wouldn't be.
Yes, I would agree on that. Yes, if you want to have launching noses and gantries and stuff like that in the project, it would make sense that you have these temporary beams also. Of course, definitely.
That's the reason I raised it, because I saw the gantry, which is
exactly.
Thank you very much.
Thank you.
Sergey, the question was asked also by Rodrigo in the questions pane. I've given you the right to answer it. Do you mind just quickly summarizing your answer in that, even later when you're ready with your presentation, so everyone can read the answer?
Okay, I will do that.
Okay, great. Thank you.
Then the last part I would just like to discuss here, despite having the feedback now about the taxonomy, since it's a bit unflexible, the polls, as we stated several times, if you have any classifications, any documentation that you think we should consider, please do send us this, because if we don't have the documentation, unfortunately, there's no way of your ideas getting into the standard. So I will just quickly show what I mean. So for example, I hope I can show this, but Takashi Aruga sent me his view of taxonomy in a simple Excel sheet with some elements listed, and we will definitely study this and try to incorporate these elements listed here into the standard. And we also got some feedback from the Nordic chapter, where where they specifically go into certain elements, give us feedback, and if there's anything we should consider, we will definitely do so. We will study every documentation sent, every report sent. So don't be shy. Send us everything you have. So also a report from the Japanese chapter they sent to, regarding the requirements report. We'll definitely study this. Unfortunately, we haven't had the chance because we only had a project team meeting yesterday. So the comments here have not made it yet into the report, but it will. And one more thing I would like to just quickly go through is the properties data dictionary from the Mind project, where we have a list of properties, and because this is the most comprehensive list we have got, actually it's kind of the only one, we are basing our models for semantics on this list. But if you have anything you would like us to consider regarding properties and their assignment to elements, please send us that also. We will be looking at omni-class, uni-class, of course, the online, the standards available online, the classifications, those are easy to access. But if there's anything that we should consider and haven't found it yet, please let us know. We will definitely do so and try to get as much of your input into the new developments as possible. Thank you. Now I'm going to answer the question of Rodrigo, unless there are other hands raised.
No hands raised at this time. Anyone got any more questions for Sergey maybe before he, well, not signs off, but answers Rodrigo's question? I'm not seeing any hands raised, Sergey, so I think
Perfect.
it's in order.
Continue.
Thank you so much, Sergey, for this, and thank you everyone for joining in the polls.
Yeah, thanks again from my side also. As I said, we will consider everything you send us.
The next topic on our agenda is spatial structure. Was that up to you, Andre, to present that? Andre?
Yes, sorry. Yes, I'm here, and I'm preparing the presentation. So, yeah.
There you go.
Here we go. Yes, so this is about the spatial structure that we have developed throughout the last month. This is actually a proposal that we have developed in the overall architecture project last year. Proposal by Jim Bloom, who was member of the overall architecture project team. We have been proposing to slightly reduce the complexity of the proposed extensions. So Jim was proposing to add IFC built facility as a new super type above IFC building, road, railway, bridge, and tunnel. We are proposing not to call it IFC built facility, but instead IFC facility. And with respect to then the actual facility decomposition, we also propose not to call it built facility decomposition, but just facility decomposition. And then we would have building story and just IFC facility as a subtype of this. No, it's not IFC facility, but IFC facility part. It's kind of hidden here due to the do my windows. I try to remove this. Maybe you can see it better here. Yeah. So it should work like this. So yeah, this is the facility part, which would be a new part here, which would have more or less the similar meaning as IFC building story for the buildings. A slightly different approach would be that we do not have the new super type IFC facility decomposition, but instead directly have only facility part and building story. This is still something to be decided. It's not super important, but maybe this is easier for the software vendors to implement. Okay, then we come to the actual spatial structure of a bridge. So we propose that we have two parts, which is the substructure and the superstructure. Both of them would be modeled as IFC facility part, and we propose to have new predefined types for superstructure and for substructure. And of course, we would also have a new element IFC bridge, and the rest is more or less the same as for buildings. So we have the project, which aggregates a site, the site aggregates a bridge then aggregates the two facility parts, which are the substructure and the superstructure. Here you see how the substructures then refined. In this case, we have everything which belongs more or less to one abutment grouped by using an IFC element assembly. Of course, this is optional. You don't have to do it like this, but this would be one option to use this grouping by using element assembly. So we can have the abutment, the number of bearings, and the number of piles being aggregated into the element assembly. We have here the same for the middle part of the substructure. Again, we could create an assembly for this. Here we also have IFC bearing, which might be a new element for the IFC data structure. Here's the superstructure. Again, the superstructure is one facility part. Then in this part is contained everything which belongs to the superstructure, including the actual deck. The deck would be modeled as an IFC slab. We could have the gutter modeled as IFC beam. We could have the coating modeled as IFC covering, and the railing using the existing IFC railing. So this would be one option how to model this superstructure from a semantic point of view. Yeah, here's one slide from the Finnish chapter. Again, using a bridge and describing the different parts. In this case, it's the substructure, the superstructure, the surface structure, the equipment, and the bridge site as a whole for the entire project. And here we see how the facility part is used for the individual elements, for the surface structure, for the superstructure, and the substructure. And you can see the different elements here. Also, the element assembly for bridge pier is included here. Here's a German example, again using project, site, and bridge, and then using IFC facility parts to describe the deck and the apartment. It's basically the same approach as in the other parts. Here we have the question of correct term, bridge cap. We already know it's not correct. Instead, this would be the parapet, exactly this element here, which can be modeled using existing types and which can be assembled into the deck. So we would have the entire deck using one assembly here. And this is then embedded in the facility part. Yeah, this is another example where we use a facility part and then refer to the different elements using walls, footings, and piles. and they refer then to the individual parts like the wing wall, the head wall, and the footings, using more or less existing structures. Only the bearing would have to be additionally added here. One example from China, basically again the same structure. We have the bridge, we have facility parts for the different elements, again the abutments, the girders, and the piers. So slightly different structure. It does not make the differentiation between the superstructure and the substructure, but of course this is also possible using the data elements that we provide. So this is maybe an important message here, that you are still free to have organizational guidelines or national guidelines on how to use the different elements for composing the bridge. You don't need to follow the proposals that we are doing here. We just check if the different views are possible to be reflected by the data structures we define. For example, our Chinese colleagues, they would then make use of an assembly to describe the pier structure here, with a pier body, with a tray, with a pier cap, bedstone, and then the actual bearing. We do not necessarily need for all these elements new elements, new IFC elements, but we will make use of existing structures to the largest extent possible. Yeah, this is again other possibilities to model this. And yeah, that's all I wanted to show you about using the new facility part. Maybe one thing that I missed is that the facility part can have itself included other facility parts, so this can be repeated, I would say, unless or limitless. So you can have these nesting structures where facility parts compose facility parts, compose other facility parts, and so on. So this is a very flexible structural element that can be used in any way you want to use it. Maybe one question to the expert panel that we could discuss here is whether the picture that's shown here fulfills your needs with respect to the spatial structure of a bridge, or if you maybe have another view on it where we need additional elements in the poorly spatial structure. Or any comments or discussion about this?
So if you would like to provide any comments for Andre, please feel free to raise your hand or add these in the chat. I have no raised hands at this time, Andre, and neither do I have any messages in the chat.
Okay, no problem, no problem. So please have a careful look on this document. Also, we will distribute it, and yeah, and we expect your feedback with respect to the spatial structure. We will have to align this also with the spatial structure of the roadways. So there might be something that is maybe even broader, including also the roadways, and then having the bridge as part of the roadway. But this is something that we have to coordinate with the new IFC road project, which is going to be started very soon.
We've gotten at least one commitment from Andrew. Andrew says in the questions panes that he will be sending you comments on this issue. So,
okay, very good, thank you.
I'm just going to make you the answerer of the question by Andrew, and maybe you could add your email address in there so he knows where to send it.
Yes, sure.
And if you do send to all, then everyone then has your email address to answer, to provide feedback.
Yeah, all right. Oh, it seems that I'm not allowed to send to all.
It's strange. Sorry about that.
No problem.
Maybe the chat's easier. Yes, thank you. Let me try and answer it for you, see if that works. Type, 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 type. Let's try it again. Everybody now should also be able to read Andrew's commitment, so his question, and my answer from Andre, which includes his email address. So please provide any feedback on spatial structure to Andre, and we'll make sure it gets to the correct place, other projects.
Okay,
Yep.
Thank you.
Where did my screen go? I'm sorry. It's being a little bit difficult today. I'm very sorry for that. There we go. So if we had time, we were going to discuss maybe some properties, get to some more questions. I don't know about you, Andre. How would you like to continue this meeting? Because we're already getting close to 3 o'clock.
I propose. I think we have already discussed the most important parts. So maybe we can shortly discuss how we want to proceed with the properties. And I think we do not have to run through all the properties, but maybe Sergei can just present our approach of handling the properties using BIMQ, and maybe shortly also presenting how these properties then will be fed into Building Smart Data Dictionary and can be accessed by software vendors.
Yes, sure. Just a quick guide to how we are handling properties. So first of all, we are gathering input data, such as the data dictionary from Mind that I showed before, where they have property sets defined and assigned to elements already, or to groups. And these will then make it into BIMQ, which is an online server where we can import the properties. For example, this is the Mind. So this property set that we got from the Mind project. You will see that the groups like such as let's find the first one that we already have here. So, for example, bill information, page number, bill information would be the P set, page number, line number are the properties inside this group. So we imported this to the online BIMQ, online server BIMQ, and these properties are then listed here. The taxonomy is also available. The taxonomy with this basic breakdown that we have was also defined in BIMQ, and what we are doing next is combining these two separate lists, so elements and properties, into our requirements. And for example, now this is probably not the best example since we just got feedback that Approach Lab is maybe not the best naming for this. But for example, we can then just assign the property sets to these elements. Let me just quickly turn off description. These properties then get special units. These are not yet filled out because we haven't defined the data types yet, but we will do so eventually. We will then also define exchange requirements in the form of exchange models, so MVDs. Basically, unfortunately, I have none of them defined yet, which could be turned on in the requirements view. And these will then get values. So is the property required? Is it not required? Basically just this decision. And another thing I have to show is, so we currently have the IFC data mapping. So for example, for approach slab, we already mapped this to IFC slab, which is kind of obvious since it's a slab. So this will also, this information will also make it into our properties, like having specific P sets that should be available in the schema. So the official P sets and the national P sets will then be mapped to this IFC column. And with this, we can then generate an MVD XML and import it into IFC doc. We have a certain workflow, of course, because these data dictionaries should make it first into the in the official schema, in the international schema, so that we have certain properties already available that should be valid in most or even all countries. Laura, do we maybe have the sketch available in Google Drive for this meeting? That would make...
Not in this meeting. I could try and find it for you if you continue talking.
Yeah, okay. So we actually then created a workflow where the data dictionaries first make it through the filter, which is the project team, into BIMQ, where they are mapped to IFC. This information then goes over to IFC doc, where the official documentation for IFC will be generated. This documentation will also be available online, of course, in the form we are all familiar with currently. And if we look at the property sets, for example, here, these bridge specific property sets will, of course, be in such lists, available in such lists. What comes next is that from this definition of property sets and properties, we can publish these properties to the Building Smart Data Dictionary. And what remains to be done is that national properties like the mine project, for example, that we are using as a basis, for example, here, those national properties have to then be mapped when they are published to BSDD, of course, then have to be mapped and maintained as equivalent properties to the official properties. So for example, let me just open BSDD quickly.
I found some information. I've saved it to the Google Drive for this folder, and I will add it in the handouts. Just not entirely sure if it's the last version that's available, okay? So.
Okay, let's just see what kind of a...
I'll make sure.
So if we look at BSDD, for example, fire rating is such a general property of several elements that's required, and therefore, of course, it made it into the official schema. And if we look at fire rating for slab common, of course, we will see that this property is an IFC property. I mean, it's a property from Building Smart. Here we have the mapping. If we then have some national properties defined specifically for bridges, they should definitely map to existing properties. But in case there are no existing properties, you can still maintain your properties in BSDD, but they would just not have this mapping to PSET SLAB Common Fire Rating, for example, which is the official building smart property. You can see this immediately with this logo here in front of it. So this is then the responsibility of national chapters to maintain these references to the official properties.
So Sergey, Google Drive is still syncing in the background. I
Yes.
have added it to the handouts. Can you see handouts?
Let me quickly open it. Okay, I have it. Is it AD3? Managing properties, right? Yeah.
Yeah, I'm not sure if that's the last version of what you meant, but that's what I could find. 2nd of November.
Yeah, perfect. This is the one I was looking for. So this is just what I explained before. We have these national properties from Mind defined in the Mind project in the form of an XLS file, so an Excel sheet. These will be fed into BIMQ. In BIMQ, we will map them and try to find a common ground of which properties we would like to see in the IFC 5 extension, or maybe if there's a 4.2 extension for bridges, in the 4.2 extension, and of course in IFC 5 afterwards. These are then fed to IFC doc in the form of an MVD XML file. We all know MVDs. MVD XML is the formal digital representation of MVD, of an MVD. So this MVD XML is then fed directly into IFC doc, where we can publish the properties to BSDD, so Building Smart Data Dictionary, and we can also generate HTML documentation. So this is then where the circle closes. The Mind properties can then be fed into BSDD also, but the ones that should be mapped to the existing IFC schema properties should also be mapped. So this is where the last arrow comes from, the one from Mind to BSDD. This is how we would see the perfect circle for, or the perfect workflow for defining properties and then maintaining them in the BSDD, so they're available online and to everyone, of course. We also have a description here of how this is supposed to work. I hope it's not too detailed or complicated. Just if there are any sections that are not clear, please just ask and we'll try to answer.
So I'm not seeing any raised hands or questions right now. If any of the experts have any questions about the approach to properties, please let us know. We're more than happy to unmute you. I'm not seeing any raised hands, Sergey, so I'm assuming it was okay for now.
Yeah, I think when we actually come to this part, that we have to define some properties for our elements, that's when we will have to get some feedback.
Okay, thank you. I see that Karen is raising her hand. Let's try and unmute her. That's still not working. Karen, any way of sharing your thoughts with us through the chat or the question? Because I still cannot unmute you. Oh, she's been emailing me in the background. I'm very sorry. So we do have some questions from Karen. her last question, at least in my email, is about, we would like to see foundation system as a spatial structure. So I'm thinking that's a remark towards Andre.
But do you mean foundation system? Because systems are not spatial structures. It's actually 3 levels of, or 3 branches in IFC how to model stuff. So we have products, physical entities as the first one, then you have spatial structures, and then you have systems. So systems and spatial structures are probably not the same. Hope we are not confusing anything yet.
Okay. Maybe you can also add your answer in the chat just to make sure we have your answer back written. Because I'm still waiting on to see if I get a response through my email. But it's
unfortunately I cannot chat to everybody, only panelists and organizers.
You are a panelist.
But that's only to our group, not to the entire group, not to everybody.
Okay, never mind. She says foundation then. So instead of foundation systems, just foundation. She would like to see foundation as a spatial structure.
I think that was already addressed by Andre in his presentation.
Yeah.
Facility part.
You can do this. So this is actually, this is the flexibility of the individual organization. So also in our discussions with the Chinese colleagues, it became clear that every country or every client organization has different demands regarding the spatial structure. So using IFC facility part and how to use it is essentially free to the client, and how he demands his planners, his designers to use these data structures. I propose that we, as Building Smart International, give some examples and maybe also advices how to use the data structures. And of course, we define the data structures, but how you would like to use them in your project is then up to the individual authority.
I'm trying to.
In our proposals, the footing or the so the foundation itself was not like an extra element, but on an extra facility part, but we modeled it now being part of the substructure. So in the substructure, you have elements like this one here, like the pile, and the pile is then part of the foundation system. And the pile in this case is part of the element assembly composed of the abutment, the bearing, and the pile. But if you have maybe other proposals, then it would be nice to maybe also see an example from Karin, how they want it to be modeled.
Okay, so Karin, could you please provide examples of how you would want to see that modeled? Okay. And she had one more question. She missed some part, but did you talk about the specific bridge railing as part of the bridge?
This is something I only read today, that we have a specific railing for bridges. So not only the railings next to the sidewalk. I think this bridge railing would have to be somehow, or just the main requirements, or what is actually meant, would be very helpful if we could get some information on that from Karin. Because currently I'm not sure if it's a parapet or if it's some special rating, or what exactly this bridge specific railing means.
Okay, I've added it in the chat. So Karen, could you please also provide some more information for Sergey so that he can model it? I'm sorry, I'm also getting a message from Andre saying that he has to hurry along to a next meeting. So Andre, thank you for being here. I think we're getting to the end anyway, if no one else has any questions.
Yeah, I have to say goodbye. I'm sorry, I have the next appointment. So I thank all the experts for their input. And as Laura said, please send me your feedback and your input, and we try to consider it for preparing the final version of the requirements analysis.
Maybe just another example of how facility part can be used. We've seen the German version with substructure and superstructure, and then we have the Chinese version where they used facility part to have an organization of girders, abutments, piers, and so on. So this is another option of how to use it, and we're kind of very confident that even if you want to use it for as a, I don't know, as a spatial structure for footing, no problem. You just give it a predefined type footing, and you should be ready to go. If you want to represent footing as a physical element, then you still have element assembly, also has a predefined type. But for spatial structure, just use facility part.
Okay, thank you, Sergey, for that explanation. I don't see any more raised hands.
I hope I answered the questions. If not, just Karin should have my email address anyway, so we can continue the discussion.
Good idea. So Karin, please feel free to contact Sergey, and you two can continue the discussion. Sergey's more than open to also maybe having a meeting, even if that's necessary, right, Sergey?
Yes, of course.
Wonderful. So I think we're getting to the end of this meeting. If there are no more questions, I'm just going to give it a couple of seconds. Any of the experts want to add a last question? If not, we haven't scheduled the next expert panel yet. I will be coming back to you soon with the dates for the next expert panels in 2018. So you'll be receiving information from me on that. And I was wondering if anyone has any other business. Any one of our staff or panelists would like to say anything? Tim, Stefan, Song, or Claude? No, I'm not seeing any raised hands or questions from the experts either. So I think we're at the end of our meeting here today. Thank you, everyone, for participating in our polls, for your feedback, for your reviews. We really appreciate the feedback from Japan and from the Nordics. Thank you for your very deep review of the documentation. And please refer to Google Drive for any documentation. I'll also upload the chat into that, which includes actions, but I will also be sending around minutes soon. So thank you all in advance for your review. Sergey, anything else you would like to add before we close?
Just thank the Nordic and the Japanese chapters for the reviews. Really helpful. Thanks.
We really, really appreciate it. I see Rodrigo has added one question. Rodrigo, would you like to share anything before we sign off?
No, I was only just thanking Sergey, Andre, and yourself for the event. Very nice.
No worries. Thank you so much for your feedback. Thank you. Thank you, everyone. Have a good day.
Have a great weekend. Thank you.
Thanks. Have a great weekend also from my side. Bye-bye.